Okay, let's do this. Today I'm supposed to be talking to you guys about simplifying exponential expressions that are a little bit more difficult than just translating the properties that you see in front of you. That means that you're going to have to know the properties that you see in front of you. So, write them down, screenshot them. I don't really care. I'm going to be referring to them, and I'm not scrolling back up later. So, do with that what you will. You know what sucks about these problems? They don't have any real steps. There are some general flow things that we'll talk about in a little bit, but there's no real step. Each problem is its own unique person. Isn't that just a really comforting thought? So let's see what I mean. So we're going to simplify each of the following using only positive exponents and radicals. So our first example looks a little bit more complicated than it actually is. Think about the order of operations here. You would take care of the stuff on the inside of the parentheses, and then you would distribute inside of it later. So, simplify the stuff inside the parentheses, and then distribute the 1/4 to the exponents in your simplified answer. In this case, our inside consists of x's and y's separated by multiplication in both the numerator and the denominator. What this means for us is that we can take a look at the x's and take a look at the y's as if they were both their own separate problems. In both cases, we have a classic quotient rule, which means that what we're going to do is we're going to take the higher power of our variable, subtract the lower power, and then put our solution in the position that the higher power was in. In other words, we're going to do x to the 7th minus 3, and then take that and put it in the numerator. And then we'll do the same thing with the y's, but oh no, there's nothing that we can compare y to the 9th to. The solution to this is simple. If there's no exponent, it's just assumed to be 1. So our new denominator is going to be y to the 9 minus 1, and then we got to remember to raise the whole thing to the 1/4. This will leave us with x to the 4th over y to the 8th, all raised to the 1/4. Now we can distribute that 1/4 into these parentheses, give it to the 4, give it to the 8. When we do that, we're going to have x to the 4 times 1/4, take a look at your properties if you're not sure, and then y to the 8 times 1/4. This will leave us with x to the 1 over y squared. Hey, wait a minute. It's supposed to be y squared. What kind of hacks are running this stupid place? Anyway, if you wanted to rewrite it, x to the first is just x, and then that's supposed to be y squared. Bunch of dopes. Whatever, I guess I get paid either way. Alright, next example. So this one may look a little bit more complicated, but it's really not. We just have a different set of things to worry about. In either case, you're going to want to simplify both the top and the bottom before you continue on with this thing. So in this case, we're going to want to distribute that 2/3 into the parentheses, which means that our new numerator is going to be a to the 1/3 times a to the 10/3, b to the minus 4, and we can't simplify our denominator at all, so it's still going to stay the same at a to the 5th, b to the 7th. Now, we have our additive property right here, meaning we have the same base. So what we're going to do is we're going to add the two exponents together, 1/3 and 10/3. Nothing to combine that b with in the top, so that stays as b to the negative 4. And our denominator, once again, is going to stay the same. When we add these together, we're going to get a to the 11/3, b to the minus 4, over a to the 5th, b to the 7th. Now we have something that looks a lot like what we had in the first example. So we're going to take a look at the bigger power, in this case the 5, and we're going to subtract the 11/3 from it. Since the bigger power of a was in the denominator, we'll write our solution in the denominator. So it's a to the 5 minus 11/3, and then 7 is bigger than negative 4, so our next term is going to be b to the 7 minus negative 4, and hey, there's nothing left over. So what are we going to put here? If there's nothing left over in either the top or the bottom, just put a 1. So, when we are finally done with our subtraction, we're going to have 1 over a to the 4/3, do your subtraction there, b to the 11th, and hey look, they did it right this time. Congratulations. I still can't believe they fluffed it up. Like, really, you're going to publish this still? Okay. So, on to the last example here. This is going to be a nice combination of the first two things that we just did. Specifically, we have to simplify the top before we can do anything else, and when we do that, that means that we have to distribute the 1/2 in there, so we're going to have x to the minus 2, y to the 3rd times y to the 2 over x to the 6, y to the negative 5, because we can't simplify the bottom. Of course, we can't forget that 1/5. Now let's combine our y's in the top. We're going to get x to the minus 2, y to the 5, over x to the 6, y to the minus 5. All of this raised once again to the 1/5 power. And now we have an analog of the first problem that we attempted. So this time we're going to have x to the 6, and then we have x to the negative 2, which is going to give us x to the 6 minus negative 2 in the bottom because x to the 6 is bigger and it's in the bottom. Similarly, on the top, we're going to have y to the 5th minus negative 5, and once again, all raised to the 1/5 power. And when we simplify this, we're going to have y to the 10th over x to the 8th, once again, raised to the 1/5 power. You tired of that yet? Well, lucky for you, we can finally get rid of it. Now we're going to distribute the 1/5 to the 10 and to the 8 in the denominator there. So, rewriting, we're going to have y to the 10 times 1/5 over x to the 8 times 1/5. And simplifying that, we'll be left over with y squared in the top and x to the 8 over 5 in the denominator. Now, the directions told us that we couldn't leave any fractional exponents, which means we have business with that 8/5. So we can write our answer one of two ways. Either y squared over the 5th root of x to the 8th as one solution, or, on the other hand, y squared over the 5th root of x in parentheses raised to the 8th power. Either one of these is acceptable. There, we're done. Oh, tips. Remember the order of operations. Do those things. Basically, just simplify the inside of any parentheses that you have first. If you have a fraction, sometimes you gotta simplify the numerator and the denominator before you can do anything else with that. Okay? Are we pleased? Thanks for coming. Hey, I was promised wings, man. Yeah. Buffalo. Level 3. Yeah. Bring 'em. Bring 'em.